Okay. All right. Well, yeah, I'm Will Eastcott. I'm the original founder of PlayCanvas. Yeah, I've been doing that for about 15 years now, and yeah, so now we do it as part of Snap Inc. But yeah, that's me. I kind of run the team and also get involved in a little bit of software engineering now and then, but a bit of everything.
Yep, and I'm Donovan. I joined the team about 8 years ago now. I'm a software engineer. I've been working quite heavily with Gaussian splatting on the rendering side and SuperSplat editor and our SuperSplat publishing platform as well. Great to be here, Michael.
Yeah, no, thank you both so much for being here. And kind of as we start to go through this, I actually wanted to quickly go through an overview of PlayCanvas, because there are so many pieces to now the PlayCanvas ecosystem. You have the engine, you have PlayCanvas React, you have the web components, you have the actual just general editor, you have the SuperSplat editor, and the model viewer. And so there's all these different pieces and bits that make up PlayCanvas now. So would you mind just kind of like giving an overview as to like this giant ecosystem that you've created over the last like 10 plus years?
Sure, yeah. I think because in the first few years of PlayCanvas, we were really focused on the editor. So most people think that PlayCanvas is this kind of like online editor where you build 3D apps, which is true, but I'd say over the years we've turned into a more like general purpose, open source platform for building web apps that have like real-time graphics featuring prominently in them. So yeah, like everything that we do is powered by this open source PlayCanvas engine, which is just a JavaScript framework that sits down on GitHub under an MIT license. So everything that we do, some of the stuff you mentioned, like we have a GLTF and Splat viewer, we have the SuperSplat editor, we have the SuperSplat viewer, we have the PlayCanvas editor, and a bunch of other products besides. They're all powered by the PlayCanvas engine. So no matter whether you're just a JavaScript programmer that wants to build a 3D web app, or you want a declarative interface through web components or React, or you want a Unity-like environment, then there's the editor. Like there's a flavor of PlayCanvas that should suit everybody, basically. But yeah, like we're really these days gatekeepers to all of these open source code bases, and we have this big community of open source developers that contribute to them. So yeah, we're just driving that forwards, and obviously today we're talking more about the Splat side of things, but we have this kind of track record that stretches well before that is more kind of like traditional mesh-based technology. But yeah, like we're really fired up about the Splat side of the business.
Yeah, and I'm very, very excited to talk about SuperSplat, because I think that you would be very hard pressed to find a more commonly used editor in the world of Gaussian splatting, and we'll talk in just a little bit as to like why that is. But I do kind of want to build like this like framework as to like how we arrived here and like what that initial like need was with like the surrounding like PlayCanvas engine and building it out to today.
Do you remember those early days? how it all played out?
Vaguely.
You must do. You were the one who implemented the first version of the. We had the renderer first, right?
Yeah. So I guess we had been a traditional kind of graphics and mesh, rendering technology kind of engine at the time, and I guess this was a year and a half ago.
It's like August 2023.
Yeah, and when the INRIA paper landed, just like everybody else, we saw this new technology. We thought it was interesting, and I think we saw that it could potentially help our e-commerce clients quite significantly, being able to digitize things, physical objects quite cheaply and easily, and then being able to display those, in a performant way. Seemed like a really good potential win for our clients, and it was unproven technology. It was an exciting space, and I guess up to that point we had been building the components that we needed to put something like SuperSplat editor together. So we had, at that point we had quite a stable graphics engine in place. We had a windowing system in place with PCUI. And we had at that point written a few applications, standalone open source applications that were useful on their own. And I think things just came together really nicely, where we saw a need for people wanting to clean up their scenes, choose the floaters and delete those. And there was no tool that did that. And we thought we could quite easily write something like that. So it was really just jumping in to solve a need that an immediate need that we had and that we saw people would have. So we took a dive into the unknown because it was an unproven technology at that point. But we were excited, I think, just like everybody else. And I think it's worked out well.
Yeah, exactly. And your team has like worked so quickly too, just to like constantly add new features and iterate and be able to like merge in these really exciting developments too. That's kind of kept up with like the very frenetic pace of research. So it's been like a really great joy to be able to use the SuperSplat editor. And as we can like even talk about some of these like core features, like you were mentioning, like you're being able to clean up individual floaters. So like SuperSplat has like these two different modes where you have like centers and like rings, for instance, where you can kind of like toggle between if you're trying to do like very local adjustments, you're trying to remove like very small localized floaters, or if you're trying to just like move everything from forward to the entire through the rest of the scene. There's a lot of editing options in SuperSplat. And so I do want to ask as well, like how seeing that this Gaussian splatting representation came out where it's using traditional like rasterization. It's using a lot of the same like elements as perhaps some of the technology that you've already built out. I am curious, like how were you like able to like leverage your existing stack to better like now pivot into a very emerging set of research, but still be able to like bring a great like web experience to your users?
Should I take it one too?
Yeah, sure.
I think it was quite straightforward in the sense that there was a structure in place for controlling the graphics card, for example. We had a system in place for constructing chunks of shaders already. This was a proven kind of approach to web graphics, and we were, as a team, we were obviously familiar with the engine, so we were able to run with that quite quickly. I think the other advantage we've had with the engine is, for example, over time we've added support for WebGPU. So part of our team are creating the general technology on browsers, and the other side of that is leveraging it for these specific applications. So I think having all the pieces in place in terms of the camera projections, in terms of the debugging, rendering, and the shader chunk technology meant that we could just jump on that quite quickly, and apply those to the techniques that we didn't invent on the web. We were also using other open source viewers as reference. So it's a big community of open source developers that have actually resulted in what we have today. We've been given, but we've also taken from the open source community. So I think that's worked out very nicely.
Yeah, no, I completely agree. And so, yeah, I have like the push notifications, enabled for the different PlayCanvas, repositories. And it's really awesome to see that the level of like engagement from the community in terms of people either creating like issue requests or pull requests for like, additional features and capabilities.
Yeah, I mean, actually, because we released SuperSplat. We just did a release about 5 minutes ago. And actually, the main feature that delivers completely came from an open source developer. So yeah, like it's really nice to see that that there's like a certain category of developers who are just really enthused to kind of contribute and spend a bunch of time helping push the editor forwards. So yeah, it's working really well.
So one of the questions that I wanted to ask is, as we kind of like alluded to, there are a lot of different components that all really like serve each other quite nicely in the PlayCanvas ecosystem. But I do want to like ask in terms of like the larger engine, how it is kind of like both like providing like feedback to it as well as kind of like driving the overall like goal of like PlayCanvas as like an entity.
How do you mean, Michael? Like,
So I mean, like, so you have like SuperSplat, and you have like the capability of editing, your captures, and being able to now like display them onto the web. You can export to like HTML, and it's leveraging like pretty heavily with the engine. And so what I was curious of is just like how does like SuperSplat like help inform like the general like direction of the like larger PlayCanvas initiative?
well, I mean, we get a lot of feature requests and contributions, and there's a lot of discussion that goes on in the Discord that we have, and like a lot of the technology that we have relating to splats is pretty isolated in the engine, and in the SuperSplat editor. There's sometimes stuff crops up that has broader implications to the rest of the platform, like our asset system, for example. So yeah, like the SuperSplat editor and the viewer are just like clients of the engine, right? So the more applications that we have, the more products that we have based on the engine, helps kind of shape it, and makes it more versatile to power more applications in the future. But yeah, like on the asset system side of things that I mentioned, one of the things that's cropped up is that splats are well suited to like incremental streaming, because these things tend to be pretty big, and you want to get your application interactive as soon as possible. And our asset system initially didn't support that, so we've had to start looking into how do we get these large chunks of data preloaded quickly, and can we even start doing things like just like stream Gaussians out of the buffer and get them rendered to screen quickly. So we've had lots of discussions about how we kind of like advance the engine to be able to support things like that. So yeah, that's one example. But I mean, at the end of the day, the SuperSplat editor is kind of like one small part of what we do. So it doesn't tend to have like far-reaching implications for the rest of the engine.
Got it. No, I appreciate that. As you're kind of like mentioning, like some of these like technical challenges that have cropped up as you've been working on like either like the SuperSplat editor or viewer. At the same time, there's been like so much research progress as well, in like the research world. And so I've been kind of like curious, like how are you able to keep up with the pace of research and be able to like incorporate some of these updates like the self-organizing Gaussians, because there's so much interest and excitement around this pace of research. But I can imagine as like from like being like an engineer, there's a lot of technical requirements and making sure that things are going to scale nicely. But you guys have been able to really ship a lot of these functionalities. So I've just been curious, like how have you guys managed to keep up with everything?
You mentioned the self-organizing Gaussians compression that we announced maybe a month ago, and it's funny how that came about, because it wasn't because we read a paper and did some kind of due diligence to figure out like it would work well in the engine. That almost completely came from an open source contributor. So there's a guy in the West Coast called Vincent Wu, who was playing around with technology, and he built a great technical demo that has the Sutro Tower in San Francisco scanned into a Gaussian splat, and it's this really cool interactive experience where you can explore the tower, and there's like annotations and stuff. But it was several million Gaussians, and he wanted it to load super quickly. So he did the investigation into SOGs, and then contacted us to say it would be great if we supported it. So he kind of did the groundwork for us, and that's a really nice way for us to work, because as you kind of alluded to, like there's so many papers covering so many different techniques, and frankly, we don't really have the time to go through and investigate all of them. So if an open source developer comes to us and say, hey, this is quantum leap over what you're already doing in terms of, like, we had a compressed PLY format that we developed internally. This outperforms it by about 3.5x. While we didn't do a serious attempt to stack it up against every other technique that's been proposed up until now, we thought it was sufficiently impressive to integrate that. So that's kind of what we did, and yeah, Vincent was a huge help with getting the tools up and running, and he also introduced us to the German Research Institute. Is it HFI?
I think Fraunhofer or Wieland Morgenson.
Yeah. Exactly. Yeah, he introduced us to Wieland, so we had a few calls with Wieland, and yeah, just really fun to work with them as well, and so that's kind of how it came about. But yeah, that's a good template for how we like to work. I think if either the researchers, open an issue on any of our tools or runtimes and says, hey, we've done this cool thing, this is the path we see to integrate it into tools that are actually practically used by the 3D Gaussian splat community, then it's much more likely that we're going to move on it rather than just having a link to a paper, because like I say, it's really hard to get the time to do that investigation. But yeah, so that's one example. Can you think of any other research papers that we've been looking at recently?
Stochastic alpha. So we do pick out occasional papers to kind of investigate further, because the advantages are so great. We do have some restrictions on the type of technology we can take, though, because ultimately we wanted to run broadly on within the browser on loads of devices, VR devices. We want to be able to provide this as a solution to end users as quickly as possible. So that does limit some of the scope of what we can consider even. Many techniques require compute shader, for example, and it's just too early for us to move everything over to WebGPU, for example. But yeah, we did spend a bit of time on that. That's the only other one I can think of right now, that if we could get that working, it would be awesome. Yeah. That's going to require a bit of work, on that side. So yeah, occasionally we do, but mostly it's driven by users telling us what they want, what they need, and coming up with these contributions like Vincent did.
Yeah, and I actually want to talk a bit more about the demo that Vincent released, because I think that it really illustrates the versatility of Gaussian splatting as an actual imaging medium, in that we now know that we can get pretty lifelike 3D from normal either 2D video or images, but I think what's really exciting about the technology too is that it can do more than just represent the visual reconstruction of the world, and you can start to layer in more interactive elements on top of that. And so what I really love about Vincent's demo and some of the other ones that I've seen is that ability to go and place these actual what I call spatial annotations at a given space to say and there's so many use cases for this, which we can maybe talk about in just a minute, but just in the case of Sutured Tower, it kind of breaks down this is what each part of the tower is responsible for. And so what I wanted to actually kind of chat with a bit more is some of these additional layers that you can add on top of it as just a pure visual medium.
Yeah, I mean, so I actually wrote that annotation system one weekend, and open sourced it as a script as part of the core engine, and then Vincent grabbed it, a bunch of other people have used it in their demos as well, and based on the fact that people seem to like it, we'll integrate it into SuperSplat, and it means that you can just directly in the editor just start creating these annotations. But there's all kinds of additional stuff that we've had requests for since we released SuperSplat. So annotations, of course, that's one. But also things like 3D audio is another thing, because when people go out to a location and they capture the photogrammetry, they can also capture some they can sample some sound from that location, and so splats work really well in an immersive context. So what better way to immerse people than also give them the audio from that location? So that's something else. But yeah, just being able to improve performance as well is like really important for immersion as well. That's something else that we're spending a lot of time working on right now. So, implementing things like LOD and sort of streaming of some of the larger scan spaces, that's also kind of important, and getting all this stuff to work really, really well in XR.
Yeah, and I'm curious too because when we were first starting this conversation, you started to say like, okay, clearly there's a lot of great use cases for e-commerce customers, to really represent like some either product or something that they're selling. But I'm curious too, as like companies and more people have started to realize like this will actually work on anything. Anything that is occurring in the physical world can now be reconstructed in very lifelike fidelity. Have you seen like an increase in industries or companies or corporations that have either reached out to you or like created something with the PlayCanvas ecosystem?
Yeah, I mean, we've seen a lot of companies reach out to us and adopt PlayCanvas to render splats. So I'd still say it's early stages for like various verticals to be adopting this stuff, and there's still a lot of learning going on and a lot of education that we've been doing to help companies understand how they can be applying this technology. But if you were to Google PlayCanvas awesome list, there's a 3D Gaussian splatting section with maybe like 10 companies or applications of Gaussian splatting. So there's a company that sells golfing equipment, and they've scanned a bunch of like golf clubs and some of their products. There's like a company that has published like an interactive experience for a new real estate development, like a big block of modern apartments, and you can kind of look at an external view where they've combined like drone photogrammetry with like a synthetic splat of the new development, and then you can look inside and see the kind of like internals of some of these apartments, and again that's like a synthetic splat. But again, like really cool application. I guess when we started originally, we thought all this would just come from like real photogrammetry, but some of the coolest stuff that we've seen has been photogrammetry rendered in applications like Blender, where you can take CAD models of products and you can render like really beautiful photogrammetry that's got like full path tracing enabled, and the level of realism is absolutely insane. But all of this stuff is like captured and baked into spherical harmonics, and it just ends up looking fantastic. And the other cool thing about that is like if you're using it in an e-commerce context, you can automate this pipeline where you go from the rendered photogrammetry out to the splat. And if you're automating it, it's a very simple matter to then also generate levels of detail. So you could generate like a 4 million, 2 million, 1 million, and 500,000 splat version of your product, and then serve those up depending on the device. Whether you're on VR, whether you're on a high-end desktop. So yeah, like the workflow to build this stuff is now getting pretty nice and easy. And if you compare that to a traditional flow where you would need a 3D artist to, maybe take a CAD model, generate a simplification of that mesh, create all of the PBR materials, bake all of the textures. I mean, that's a very long-winded, complex process that takes an artist, potentially, 1 week plus for a particular product. Now you could do this kind of stuff in just a few hours.
And you're still getting like an output that is at the very least very lifelike, if not stronger fidelity than like the longer process historically.
Yeah, I mean it kind of depends on the objects that you're scanning, because some things scan really well. So like if you were going to scan, say, an armchair, that tends to scan really well. And certain materials like fabrics and say, leather and those kinds of natural materials look beautifully represented by splats. But as soon as you get to things like vehicles, so if you have like a highly specular reflective car, actually that tends to break down a little bit because the way that Gaussians are generated, like the reflections tend to place Gaussians on the other side of the surface, and as soon as you reach a certain level of reflectance or specularity, that breaks down somewhat. But yeah, I mean, for certain products though, like it looks absolutely spectacular.
Yeah, it's awesome to be able to like see the I always get very excited whenever I see like a great capture, and when we talk about like the extensibility on the web too, one of the components of PlayCanvas, which I think is really fascinating, is the React side of PlayCanvas too. And so I kind of wanted to just like at least give like an overview as to being able to say like, okay, so now you also like want to have like more options as to like what to do with your final capture. I was wondering if you could talk a little bit about like how the React component also supports like that splat-based capabilities.
Yeah. Well, so we have this JavaScript engine, which is great, but like it's just a API that's made of a bunch of interfaces that are kind of exposed via classes, right? So as a JavaScript programmer or a TypeScript programmer, you can like instantiate all of these objects and build your application, but what React allows you to do is build web apps using this declarative interface. So not only is it declarative, you can build your applications based on pre-existing components. You can kind of compose applications from like a library of components that people have built. So we have all of the PlayCanvas engine API exposed as like React tags, and then we've built some higher level components based on these these React tags that we built. So we have a splat viewer, which you can just really easily embed it into your React site, and it comes with a like very sort of aesthetically pleasing interface that like nicely will kind of like scale down to mobile screen sizes, and it's got like a bunch of different like camera controls built into it by default, and a bunch of like a default UI that allows you to kind of set it up. So we have like this reasonably configurable component that you can just embed in your website super easily. So if you love React and you just want to embed some Splat content super quickly, then we have that. But if you want to do something a bit custom, you can also construct your own components.
And so when we talk about like mobile as well, I feel like when people see like really high fidelity captures and things like you think of like really high fidelity 3D, you might have like an association of like this would be very intensive on like perhaps like I need a very strong computer to run and distribute this to our customers. But I'm curious from like building out SuperSplat and the PlayCanvas engine, what requirements would you say would be necessary for a company to be able to have people interact with like splats on any device from mobile to laptop to PC?
So it's something we've not spent a huge amount of time doing. I think what Will alluded to earlier is that ideally you'd have, I think, content customized for each of those platforms, because a desktop machine running a 4090, NVIDIA 4090, for example, can do significantly more work per frame than a mobile phone can. And fortunately, it's not a difficult thing to implement. Just simply having different versions of the scene, high fidelity versus low fidelity, and perhaps serving one versus the other depending on the desktop of the machine that you're accessing by. I think the future probably is going to include us implementing some sort of LOD system, some sort of streaming system, which will mean that a single scene can be rendered efficiently on any type of device. I mean, that would be living the dream. We don't have that technology yet. And so up to now, I think we've been creating scenes that work well in VR, for example. VR is another very important device that we target. And these scenes tend to currently have fewer Gaussians in them. So there's a limit of about 2 million Gaussians.
Yeah, I mean, it's kind of funny because like when we started, we definitely hit the memory limitations of mobile devices. And then we developed this sort of, compressed PLY format. And suddenly, you could go from, I don't know, like 500,000 splat scenes up to like 1 million now. And then with SOGs, we've got, been able to do even more than that. So I'm not even sure what the limit is, but when we announced SOGs, we had a scan of a church in Austria from the amazing Christoph Schindler, who scanned it originally. But and that's got 4 million Gaussians, and that works quite happily on my iPhone now. And so we've definitely, the scale of scenes that you can run on mobile devices now is definitely like, it's a big leap over where we were to begin with. So I guess Donovan's talking about like some of the things that we'll be focusing on in the future that will enable us to, achieve even larger scale scenes on mobile, in particular, like it says in VR. So that's definitely a big focus for us in the future. And also, we've just kind of got to the point where we're seeing companies do interesting things around animated Gaussian splats built on top of PlayCanvas, and so also making the engine work well in that context is really important as well. So we're working quite closely with some of the companies working in that space to ensure that the engine gives them everything they need in terms of performance.
Yeah, it's been awesome to see some of the research that's been coming out on the dynamic Gaussian side. There was that very, I guess, a very like highly anticipated company that called 4DV a couple of weeks ago that just, they published a paper called Free Time GS, and then it kind of took over the internet for a few days. And I guess as you were like alluding to, they were talking. I think you also posted about it being like built on top of, using PlayCanvas as well. And so it's been really incredible to see like the ecosystem that PlayCanvas is kind of like fostering. Another example of this is actually, as we were talking a little bit about like VR, is HTC's Viverse Worlds, for instance, which is their like Gaussian splatting implementation, but it's also using you have to in order to put it on there, you have to go through PlayCanvas first as well too. So it's really awesome to see PlayCanvas kind of like spread out across like the industry and like powering a lot of these actual like end user applications.
Yeah, it's been great to work with HTC on Viverse actually. So just to plug the service, they're always looking for great developers of games and worlds. So check them out. But also Arrival Space. So Thomas, who runs Arrival Space, he's kind of integrated SuperSplat into his platform. So just to explain about it, like you can create Gaussian splat-based worlds that you can then visit with other people and interact with them in real time. So you can basically create an avatar and then like socialize with people within these Gaussian splat-based spaces. And so for creators, he actually just like cloned the SuperSplat editor and integrated it more tightly into his platform, and the actual like runtime that he's using is of course PlayCanvas as well, and it's been cool to watch that platform evolve as well. And he kind of hit a bit of a viral moment when there seemed to be quite a lot of uptake in Japan, like because when we launched SuperSplat, there was a lot of splat scanners in Japan who were posting their stuff, and then they discovered Arrival Space, and there's a lot of interest over there actually. I don't know why, and in particular it's been like particularly strong region for splats being experimented with, but yeah, it's cool.
Yeah, another really like awesome platform too that lets you like explore and like walk around and like share captures. And I actually wanted to ask you a bit about that the sharing side too on the Play Canvas side because you know within the last couple of months you've added the ability for people to publish their captures directly onto the SuperSplat website, which is just super.splat with the .at at the end. But yeah, I wanted to ask like why it's so important to allow people to like distribute the captures like easily once they have them created, and like how that's kind of played into the viewer that you've released.
Yeah, I mean, do you remember, like, originally, before we had that service, we were getting so many people just saying, oh, it'd be so cool if I could just share a link to this. Like, a lot of people were asking for that. And so I think before we even launched the website to publish to, we added support to the SuperSplat editor to export an HTML viewer that you could self-host. So that was kind of like the first step. So it became easier for people to exchange this stuff. And we had in our documentation like the instructions for how you could host the viewer on GitHub Pages, for example, which is kind of cool, but like still it's a few hoops that you have to jump through, and not everybody has a GitHub account. And so we thought we could just make this a bit more convenient for people. So yeah, we built that that site, and also I thought it'd be a nice place where people could build a like collections of their work and exhibit them.
Portfolio.
Yeah, and there's like just off the top of my head, there's one user on the SuperSplat site with the username Tippatat, and he's scanned like almost every gourmet meal he's ever had, and there's probably like 50 scans of meals he's just had around the world, and these are stunning scans of some really, really amazing looking food, and it's just really fun to browse all this stuff, you know. So and we've got the ability to to like something, and then we've got view counts and stuff. So you can filter, you can do basic filtering on this stuff too, and the search is pretty powerful too. So it's based on like a tagging approach where you don't even have to say what the object is, and we will determine what it is. And so if you type like bicycle, it will show every single bicycle on the platform. And so there's a whole bunch of stuff we could do with that in the future. But for now, it's just been really fun to watch some of this stuff roll in, because I guess when we first made that platform live, we did not anticipate some of the types of content that people have been submitting. So for example, people have been experimenting with like long exposure times and painting with light and all this kind of really creative stuff that we just never anticipated at the beginning. And so it's been like a really nice place where people can express their creativity and share new ideas, and actually kind of just like really demonstrate that Gaussian splats is a legitimate new art form.
Yeah, no, I actually completely agree with you in that, and that like I think it's really enabling like a new frontier of content creation where we're kind of like venturing a bit into like the unknown here in terms of like, will this work? We don't know until we try it, but once we do try it, we can put it out onto a platform that will allow us to share it and interact and talk to one another, and make it very easy to distribute and hopefully get feedback and then iterate and continue to progress the technology, which I'm very excited to see. I actually did not realize that you guys will do the automatic categorization as well of, say, if you had like a bicycle or something in the scene. That's really awesome to know. We have a couple questions too, and so I want to see if I could just go through them really quickly. And it goes back to the level of detail in streaming that we were talking about just a little bit ago. If there's any interest in like integrating some of like the 3D tile providers like Cesium, who have definitely showcase a lot of interest in Gaussian splatting, and they've actually like the parent company of Cesium, Bentley, has just put more stuff into iTwin Modeler to support Gaussian splatting. But I'm just curious if you guys have ventured into that world at all.
I mean, we did an integration with the Google 3D Tiles API, and we made this little product called First Tile, and that worked pretty well. That was just based on like mesh-based tiles, of course, rather than splat-based stuff. But I could imagine you could do some pretty cool stuff where, let's say, you wanted to like either create a synthetic splat, or you wanted to like insert a splat, like a really high resolution splat, within a realistic landscape. So let's say, for example, you did a drone capture of, I don't know, the Arc de Triomphe or something, and you have that as like a beautifully high-res scan, and but like it doesn't look, anchored into the world. So what you could do is you could use the Google Tiles API to pull in mesh-based surroundings for that scan. So I have seen some people playing around with that kind of stuff. When it comes to Cesium specifically, I've known Patrick Cozzi for quite some time, who's, I think, the CTO maybe. I'm always open to integrating PlayCanvas into other services and integrating with other APIs. So yeah, Patrick, if you're watching, if you want to integrate, I'm happy to do that.
And so kind of as a follow-up question to the APIs, we have another question asking if there's any plans to implement an API for developers to access splats in SuperSplat on behalf of users.
Do you mean like a REST API, so you can like search and...
I believe so, but Arvin, if you want to follow up with any more specifics, we can go through it. But yeah, I think we can interpret that.
Yeah, I mean, I don't think we thought about that super deeply, but I think it makes sense. Yeah, because, I mean, for example, in the PlayCanvas editor, we have like an asset store, and we've got our own asset store, but then we have an integration with Sketchfab, for example, and we use their REST API to be able to allow users to search for content and then pull it into PlayCanvas projects. So I can imagine that, yeah, you might want to do the same for SuperSplat content one day. But it's not something that we have now, and it's not something that we're working on right now. But yeah, cool idea.
Yeah, that's it would be very interesting to see. So one of the other questions that I wanted to just kind of chat through is we touched a little bit about like some of like the research direction and moving towards making things a bit more either like compressed or being a bit easier to stream, for instance. I am like curious as well if there's any other like general like research trends that you've been like kind of keeping your eye on or like hoping for from the research community.
Definitely,
to be honest, I mentioned the stochastic alpha paper that certainly piqued my interest because that solves so many problems, runtime problems. But many of the research papers are actually more on the training side of things. So, the cake that we've decided to cut out for ourselves is post-training, really. It's post-training, it's editing, publishing, and rendering, real-time rendering. So that kind of sums down, the bits that we're interested in.
Did you look at any of those papers around like triangle splatting or voxel-based splatting?
Only very briefly. Yeah, only very briefly. We just don't have time, to be honest. We have so many challenges with what we have already. Just getting what we have running. For example, we're integrating SOGs right now, and a lot of the challenges is getting that running well on different devices is a huge challenge. So the real big advantage with SOGs, for example, is that it solves the memory problem quite nicely. It's a much smaller set of data, but it's thrown up many performance challenges. So rendering that data very quickly on like VR devices is a problem. And so that's where we're spending our time. So for us, actually, I think I would say we spend a lot of our time engineering rather than researching or reading up on research. But certainly we're always listening to our, to our users. We use them as a gauge quite strongly, I would say. So, for example, the SuperSplat publish site, that happened because our users just kind of demanded it. The editor and the features that have gone in there largely have been down to what the editors, what our users have demanded. So that's kind of our gauge, I would say, more so than us, individually going and doing research ourselves.
And so I have more of like a general question now for you both, but do you happen to have like a favorite feature or capability of the SuperSplat editor as like a personal favorite?
What? I always thought the rings mode was just genius. I think that's really cool. But like, I'm going to say something that I added actually, which is the video rendering, because yeah, like being able to set up and render out like high resolution video of your fly-throughs is really valuable to people, and there was just like one weekend where I went home and I thought, I wonder how hard it is to get the SuperSplat editors to do this. So yeah, I just started playing around with the sort of like HTML5 video codec APIs, and it's actually really quite straightforward. So it was just like a really nice, easy to implement, bang for buck feature so there's now like this render menu in the SuperSplat editor where you can render a high resolution image or video. Yeah, it uses that code that I just whipped up one weekend, and yeah, I love it whenever there's like some just like really low hanging fruit that just gives, so much value to our users. So that was kind of cool. But apart from that, honestly, what about the data panel?
I could probably sit here for an hour and tell you all the little things that basically for me it's a case of, we added features hoping they'd be useful, and for example the rings mode, like we just added that hoping it would be useful, and it's turned out to be quite useful, and that's a wonderful feeling. It's wonderful. But I also feel like we're quite lucky in that sense that we've managed to find these features and add them, and they've been useful. The data panel is quite similar. That was just added because I needed to do some data things, and we added it, and it's quite useful, I think.
So the data panel is, just so that folks know, it displays a histogram of all the Gaussians in the scene based on like a selected property. So it could be like size, volume, color, whatever. And so you can make selections on that, and then like So there's lots. The thing about the SuperSplat editor that I think a lot is kind of maybe not obvious to people is that it is very powerful on the one side of things, but we've managed to do that in a way that keeps the user interface very, very clean, simple, and accessible. I think that's one of the big wins of the app, is that you open it for the first time, and it's just it is just very easy to use. And shout out to there's a designer who has worked with us on the interface design. So when we released SuperSplat Editor v2, that was based on that kind of took us from like a programmer UI to like a properly designed UI that made all the difference. And now I just think it looks perfect.
Yeah, no, I agree. I think it's very approachable and feels a lot more natural to people who have just used, modern software over, the last few years. And I really do love that splat data tool. Essentially, if you hit the D key, it will bring up the histogram inside of the SuperSplat editor, and then it's really helpful if you are trying to get underneath a certain splat count, or being able to see like does one small area have like a ton of splats you're representing there. It's really easy to help like cull that information. My favorite one's kind of lame, but it's the reset camera button. It's just like the most standard thing.
more likely to be able to join the team if like you've already got involved in our open source effort. So for anyone who, you know, like thinks this sounds exciting and interesting, and they'd like to join the team one day, like it's a massive tick in the box to be able to say like, oh, you know, I've already contributed a bunch of PRs to either the engine or the SuperSplat editor. So yeah, like that's probably one big bit of advice. Like that matters more than like the university you went to, or like, you know, the job you did 5 years ago. Like whether you've actually kind of engaged with our open source community, like so important.
Yeah, and it's all you know. Both the viewer and editor are completely open source as well. So if you want to kind of like dive in and either fork it or make your own contribution, you know, people are able to do so. And one last question that I wanted to chat about is, you know, we've seen a lot of interest, obviously from like the augmented reality side from Snapchat or from Snap. And so we've seen, you know, more capabilities go into like Lens Studio as well as some of their other like spectacles, for instance. And so I wanted to just like ask you about like how you could see Gaussian splatting and lifelike 3D playing a role in augmented reality at either at Snap or just in the general world.
So Gaussian splatting is already supported in Lens Studio, so you can make splat-powered lenses today. So if you're interested to kind of like publish any of this stuff to Snapchat now, then, you know, Lens Studio has your back. But what I announced at AWE that happened a couple of weeks ago is that the web browser that will soon feature on Spectacles, that will support WebXR very soon. And so any content that also you build in PlayCanvas or any content from SuperSplat will work on Spectacles. So there is a story for people who want to build sort of like traditional Snapchat lenses. They will work on Spectacles, but also now there is a developer story that appeals to web developers, people that understand the web stack, WebXR, 3D web apps. So that side of the developer community is also catered for now. So yeah, we'll be talking about more about that in the future. But yeah, it's really exciting to unveil that a couple of weeks ago in AW in LA.
Yeah, that's awesome. That's like super exciting like news to hear, and I'm excited to see it be you know, formally released. So we're pretty much out of time, but I just wanted to like pause for just any like general last thoughts about like what like Gaussian splatting and the different like gradients or representations are beginning to now like enable, both from like the content creation side in addition to like just more commercial uses, like say if you're working in like construction or, you know, geospatial or any of these other industries where you might want to be visualizing something in 3D.
Sure. Well, I mean, in terms of like the applications that I'm seeing now, you know, like, yeah, they definitely go way beyond what I originally thought. Like, we're seeing, yeah, educational experiences being built, certainly a whole bunch of e-commerce-based experiences. You know, like in sort of real estate-based applications, yeah, like all this stuff. Like I'm spending a lot of my time going and talking to. It's almost like I'm educating companies, but they're educating me too. So I'm trying to go out and speak to as many companies right now as possible to understand their customers, their business needs, and understand whether there's an opportunity here for Gaussian splatting. So. Yeah, it's not like we're just sort of like focusing right now on e-commerce and that's it. Like, I'm looking for any new potential use cases that even I haven't thought of. So yeah, that's why I kind of recommend that folks do visit that awesome list that I referred to earlier, and check out some of the really cool applications that people have dreamed up so far. And if you have any that you want featured there, just submit a pull request and we'll add them to the list. But yeah, there's yeah, like you got to remember we're just at the beginning here. We'll keep learning and exploring and finding new applications for this stuff. And I think actually that's only going to get more interesting once we have more consensus about file formats for 4D Gaussian splatting. And we've talked about 40V. That's a great start. But I think as soon as that becomes more accessible to creators, we're going to see like a whole new category of, new categories of use cases pop out of that.
Yeah, it's a future that I'm really excited to see, and hopefully, we can continue to, bring that future closer, as soon as we can. So I really appreciate both of you for the work that you guys have been doing on both, the larger PlayCanvas platform in addition to SuperSplat and the various Gaussian splatting components inside of it. So thank you both so much for joining me today, and again, really appreciate your time.
Well, we appreciate you inviting us onto the show, and love all the work that you're doing, Michael, to share all this stuff with the community. So yeah, it's a big help to us in particular.
Yeah, it's great. Thank you so much.
Cool. Well, yeah, thanks so much, everyone. And I guess we will return shortly with some more content for everyone. So thank you so much for everyone for listening in today. Thanks.
Bye.
Okay.